Alrighty, let's review for the DCA. So you should have the packet for the DCA review. Again, your DCA, the District Common Assessment, that's what it means, is going to cover the entire first 9 weeks. So everything from the first day of school back in August up until today is fair game on this upcoming assessment. This first question says, we are given A parallel to B and B parallel to C. So I'm going to indicate on the picture that these lines are parallel by including the arrows that we've mentioned in class or on our notes. So again, if you see a pair of lines with an arrow on it, that extra arrow indicates that those lines are parallel. So A is parallel with B and B is parallel with C. All right. Now we got to write a proof and fill in the reasons. We've talked about this as well, that the first reason on every proof is always your given. And that is still true in this situation. A parallel to B is the first statement that was given to us as our first statement. Statement 2 says angle 3 is equal to angle 6. So let's highlight those angles in the picture. Here's angle 3 and here's angle 6. Now focus only on those two angles. Both angles are between A and B, so that means they're in the interior region. And they're on different sides of the transversal, so that means they are alternate interior angles, which is what we've covered in the last few weeks. So since the lines are parallel, then one of the theorems we learned here recently states that the alternate interior angles are going to equal. So that is our reason we use the alternate interior angle theorem, which can be found on the pink sheet of paper that you got this week. Statement 3 says B is parallel to C. Again, that's another given statement. So you can have multiple given statements, and they won't always be given at the very beginning of the proof, which is perfectly fine. Now we're going to focus our attention on angle 6 and angle 11. Again, here's angle 6, and here's angle 11. Now, ignore A for a moment and only focus on B and C. You'll notice that both 6 and 11 are in the exterior regions of B and C, and they're on different sides of the transversal. So since they're on different sides and in the exterior region, we would say those are alternate exterior angles. And again, we've learned here recently that when you have two parallel lines, the alternate exterior will also be equal or congruent. So that's the alternate exterior angle theorem, also found on that pink sheet. Now, in order to give a reason for statement 5, we need to go back and look at statements 2 and 4. What you should recognize in statement 2 and statement 4 is that angle 6 repeats itself. Now, if I were to write those two statements side by side, maybe you would see a little clearer at the reason I'm trying to get you to notice. So I'm going to write them side by side. Angle 3 equals angle 6, and angle 6 equals angle 11. And then angle 3 equals angle 11, which is where we are right now in statement 5. So maybe now that you notice when the 6's repeat, they repeat in the middle. And when it repeats in the middle, you can delete the repeats which we talked about when we were doing our first set of proofs. So when you delete the repeat, you simply put the outside pieces together. And when the repeat is in the middle, it's like law of syllogism or the transitive property. The hint that it was transitive was because there was repeat in the middle. If there's a repeat not in the middle, it's substitution. But since the repeat was found in the middle, it's transitive. And in order to remember that, you had to go back to the property sheet from the Unit 2, where it had all the properties listed that we use for our algebra proofs and our geometric proofs. So any property we've talked about so far, any theorem we've talked about so far, could be a possible reason in any proof. Alrighty. On this next problem, it says that A is parallel to B again, so I might want to mark it on the picture so we don't forget. It wants us to find the measure of angle x, or find the measure of x, sorry. X represents an angle, and if you look, there's two angles on this picture. Both angles are in the interior regions between A and B. And they're on the same side of the transversal, so that means they are consecutive. And we talked about consecutive angles are going to be supplementary when you have parallel lines. So that means x plus 105 should equal 180 degrees. So if I subtract 105, I can find out what x would be. And that would give me 75 degrees. Question 3 says, find the distance that is 4/5 of the way from point A, which is -5, -2, to point B, which is at 5, 3. So if I were to plot those on the graph, -5, 2, 1, 2, 3, 4, 5, 1, 2 would be here. There's A. And 5, 3 would be 1, 2, 3, 4, 5, 1, 2, 3 here. That's where B would be. So it doesn't want the total distance from A to B. It only wants partial distance, a fractional distance, only 4/5. To do this, you have to go back to Unit 1, the lesson on distance and midpoint, when we talked about fractional distance. There was 3 steps, but since it's a coordinate grid, those 3 steps look like a total of 6 because you have to do it to x and then you have to come back and do it to y. So the first step is find the total distance of your x's. So to do that, you're going to take the absolute value of both x's. The x's in this problem are -5 and +5. So let's find the distance between those x's. If you use a calculator, you would find out the distance between those is 10. Or you can simply just count this direction and it would give you 10 as well. Step 2 is find the fractional distance. To find the fractional distance, you take the total distance, which was 10, and multiply it by 4/5, which is from the problem. The problem will always tell you what fraction to use. You can use a calculator to multiply these fractions, but without a calculator, I remember that 5 is half of 10, so this would give me 8. My fractional distance is 8. Now, I since the problem says we're going from A to B, so A is our start point. And to get from A to B, you have to move to the right. And since you're moving to the right and your x values are increasing, we're going to add our fractional distance from to our starting x value. Our starting x value is -5. So we're going to add 8 to this number. So when I take -5 plus 8, that would give us our new x value, which is +3. So now we know what the new x value is. We're going to have to do those same 3 steps to find the new y value. So again, we got to find our total distance between our y's. Our y's in this situation are -2 and 3. So the absolute value of -2 minus 3 would give you 5. Or again, you can simply just count the distance between A and B vertically, and you would get 5. Step 2, take that total distance by the fraction 4/5 to find the fractional distance. So 5 times 4/5. The 5's will cancel, leaving you with just 4. Those are those fraction skills we've learned in elementary school, my dears. All right. So now, again, we're starting at A, and A's y value is -2. And as we're going from A to B, you have to rise upwards. So that means you're going to add 4, the fractional distance. So -2 plus +4 would give us our new y value, which is a +2. So the final thing you would do is write it as a coordinate, which would be 3, 2. Next question says, write the equation of a line perpendicular to the line graph below that goes through the point -6, -2. So they don't want the equation of the line in the picture. The purpose of the line in the picture is to see what the slope is of the line in the picture because we need that information to go further. So when I look at this line, I need to find 2 good points so I can find the slope. So I see the y-intercept pretty clear, as well as this point right here is pretty clear as well. So to find the slope, you find your rise of your run, and you read from left to right. So when I go from left to right, to go from point to point, I have to go down 2, so that's a -2, and go over 1 time, so that's a +1. So the current slope of the line in the picture is -2/1, or simply -2. We have to write an equation of a line that is perpendicular to the line in the picture. So when we know that in order to be perpendicular, the slope has to be an opposite reciprocal, which means change the sign and flip. So it's -2 right now. It needs to be a +2. And we need to move the denominator to the top and the numerator to the bottom. So it would be a +1/2. So knowing what the new slope is supposed to be, that allows us to eliminate choice A and choice C. Now with the remaining choices, we're going to use the point that they give us and substitute the value for x and for y. So if I'm looking at B, B says that y is equal to 1 over 2 x minus 2. So when I replace x and y in this equation, y turns into -2 and x turns into -6. So now I gotta see if -2 on the left side is equal to everything on the right. So bring down my -2. Now go through the orders of operations to simplify the right. So the first thing you would have to do is multiply 1/2 with -6, which would give you a -3. Bring down your -2. Now bring down your -2 again on the left and simplify the right even more. So -3 minus 2 is going to give us a -5. And as you can see, the left doesn't match the right, so this choice is wrong as well. So your final answer would be D. And again, you would plug in -2 for y and -6 for x, and you'll see that both sides do match up. This next problem wants you to write the equation of a line parallel to y equals 4x minus 7 and goes through the point -5, 10. So this type of question is similar to the one we just did, except for now we're looking for parallel. So the equation they give us is simply just to identify the current slope. So the current slope is 4. Now when we write the new equation, we want it to be parallel. And if you remember, parallel slopes have to be the same. So that means it also has to be 4. So knowing that, I can eliminate choice B and D. And just as I did in the previous question, I'm going to substitute the x and y values to see which one it is. X is -5, y is +10. So if I'm using choice A, y equals 4x minus 10. I'm going to replace y with 10. Ooh, that's a sloppy 10. And x with -5. Bring down the left side. Carry out our order of operations. So 4 times -5 is going to give us a -20. -20. And bring down the -10 portion. All right, bring down the left side and the equal sign. And now -20 minus 10 is going to give us -30. And as you can see, both sides do not match. So it's not going to be A either. So that leaves us with only C. All right, on this question says, a piece of Miss Alford's dream picket fence is shown below. A diagonal brace is used as support. Find the measure of y. So if it's a fence, the lines are going to be parallel. And the diagonal is your transversal. So as you can see, the angles in the picture are both interior angles, and they're on the same side of the diagonal. So that means this is another consecutive situation. And again, consecutive means supplementary. So that means y plus 60 is equal to 180. So if I subtract 60 from 180, I will know what y is, and that'll be 120 degrees. We're going to take a break right here and resume in just a moment.